dugsiga boardingka iyo maalinlaha ah ee Amano boarding and day
rahmatullahi wa barakatuh. Welcome from two students. This is our e-learning program, Amano boarding and day school e-learning program, particularly chemistry subject, me Abdurrahman Musa Ismail. So we want to continue our lessons. If you remember, this is our chapter. So it was acids and bases. So we came across this part, what we call acids. We want to start this part, what we call bases. If you remember, during acids, so we have finished definition of acid according to Arrhenius, Bronislaw Lowry, and Lewis. Again, some properties of the acids. Also, we came across what we call what causes acidity. Again, we came across during that particular subtopic acids, we divided into two parties: strong acids and weak acids. So same principle, we want to start this basis. So basis or alkali. So basis or alkali are similar. You see, some alkali or most of say all alkali are bases, but not all bases are alkali. Because of what? Alkali is a soluble base. Alkali is a soluble base. So we want to look at these definitions according to Arrhenius, Bronislaw Lowry, and Lewis. So they divided acids and bases both. So they divided what we call acid. Again, they divided what we call base. So how Arrhenius divided acids, say bases. This is the definition of Arrhenius. So according to Arrhenius, this is the theory of Arrhenius towards what? Bases. So he said what? Bases are ionic compounds. That's number one. Bases are ionic compounds. When I say ionic compounds, there are some exceptions. For example, ammonia, it is a base. Again, it is not an ionic compound. So we have some exceptions, but generally, bases are ionic compounds. So these ionic compounds dissociate, decompose, ionize into metal ion and hydroxide ion, when it dissolves in water. So I want to summarize this again. Arrhenius divided base. He said number one, what we call bases are ionic compounds. That's number one. So we can see ammonia. So ammonia, it is a base. Again, it's an alkali, and it doesn't contain what we call metal or non-metal. It contains both non-metals. So it is a covalent, what we call molecular. So this is exception. Ammonia is an exception. But generally, ionic bases are ionic compounds. These ionic compounds, they dissociate, say ionize, decompose into metal ion and hydroxide ion when it dissolves in water. When that compound dissolves in water, it dissociates into two. Consider this one. Here we have sodium hydroxide. So sodium is a metal, hydroxide is a non-metal. So it's ionic compound. So if you put in this sodium hydroxide in water, it decomposes into what? Sodium ion, which is positive ion, and hydroxide ion, which is negative ion. So these compounds are called bases. So any compound, again, which is ionic compound, when you put in water, dissociate into hydroxide ion and metal cation is called base. So that is the concept, that's the theory of Arrhenius. Here you have sodium ion, which is ionic compound. We add water, with this ionization, it decomposes into sodium ion and hydroxide ion. So this kind of compound is called what we call Arrhenius base. So Arrhenius base produces what? Cation and anion, which is hydroxide ion in aqueous solution. What about Bronislaw Lowry? You see, Bronislaw Lowry, there are two different guys, but they agreed one definition, one idea. They divided base proton acceptor from another substance. Proton means hydrogen ion. So any substance that accepts hydrogen ion from another substance, this is called base. This is called base. If you remember acid, any substance that produces hydrogen ion to another substance, this is called acid. So that acid is called Bronsted and Lowry acid. So these are called what? This is the base. So this base, they divided. You see, these guys, they divided a base proton acceptor substance. So any substance that accepts a proton from another substance, this is called what? Base. Bronsted and Lowry base accepts a proton. So proton means hydrogen ion. Proton means what? Hydrogen ion. Consider this one, NH3. This is ammonia. Ammonia is a base. Here you have water. So when you add ammonia and water, you see ammonia should accept hydrogen ion from the water. So any substance. Here we have you see ammonia, it contains 3 hydrogens. And water contains 2 hydrogens. So when they combine together, when they react together, ammonia and water, you see one of the hydrogens come from the water, and combine it to this one. So this is now NH4, and here you have a single H, which means ammonia accepted. This is called ammonia. It accepted hydrogen ion from the water. So any substance that accepts proton from another substance, this is called base. What about the substance that produces hydrogen ion, donates hydrogen ion? This is called acid. So at this time, water is an acid. You see, water, it is called amphoteric. What does it mean, amphoteric? It behaves in a different ways. For example, if you add, you see, this is water. We add ammonia. So ammonia accepts hydrogen from the water. So ammonia is a base. So when you add base, for example, you have a water. If you add base water, it acts as a base. It acts as an acid. If you add acid, this water, it acts as a base. So it is amphoteric. It's amphoteric. So let us come to our point. Our point is what? Bronsted and Lowry base is accept Bronsted and Lowry base always are accept a proton. Proton means hydrogen ion. So any substance that accept hydrogen ion or proton from another substance is called what? Base. Base. Okay, Lewis is another guy. So he divided base as electron pair donor. If you remember base, Lewis divided base acid electron pair acceptor. This acid electron pair is the opposite. It is contrary. So any substance that accepts a pair of electrons, is called acid. Any substance that donates a pair of electrons is called base. Okay, consider this one. Here we have boron trifluoride, and here we have fluoride ion. So boron, this boron, you see, this boron. So boron should accept a pair of electrons from fluorine. So any substance that accepts a pair of electrons, this is called acid. What about substance that produces a pair of electrons? This is called what? Base. Base. So substance that accepts a pair of electrons is called acid. A substance that donates a pair of electrons, you see, consider fluorine. It contains 8 electrons. So it donates these 2 electrons to boron. So this is called base, and this is called acid. So you see, Lewis is slightly different. These 2 guys, because he considered at the side of what? At the side of electrons. Rather than proton. So he said Any substance that accepts a pair of electrons is called acid. Any substance that donates a pair of electrons is called base. So this is the definition of what? Lewis. So let us come to here. These are the properties of bases. If you remember the properties of acids, we said acids have a sour taste. For example, they have a pH number less than 7. We said they react with bases. They are soluble in water, conduct electricity. So these are the properties of acids. This is the opposite. Consider here bases. So it is like bases are always feel soapy. It is like a bitter taste. Say greater than 7 on pH scale. They have a pH scale greater than 7. If you remember, pH scale is in between 0 up to 14. 7 is in between. So any number below 7 is acid. Any solution above 7 is base. So they have a pH number greater than 7. Forms hydroxide ion. What are acids? They do what? Hydrogen ion when they dissolve in water. Mix it with acid. For example, if you mix with acid, they neutralize each other and form salt and water. They conduct electricity. Same principle with acids. In chlorine, household cleaners, antacids, say ammonia. These are examples of the bases. What about here? If you remember, what causes acidity? We said hydrogen ion, as simple as that. What about what causes alkalinity? Alkalinity, why I'm using alkalinity instead of saying basicity? It's the same, but alkalinity or alkali is a soluble base. So same principle, you can use this alkalinity. So what causes alkalinity or basicity? So we can simply say hydroxide ion. So the more OH ion there are in a solution, the more alkaline, the more basic. For example, what causes alkalinity? We said hydroxide ion. So any solution that contains more hydroxide ion, which means it is a more alkaline. What about the pH scale? The pH scale, for example, they have mostly, they all have what? A pH number greater than 7. So if they contain more hydroxide ion, the pH also grows up. So and the higher it is pH number. If you remember acids, the pH number and the acidity are always inverse proportional. But at the side of alkalinity or basicity, they are directly proportional. So consider here, we have some common bases or alkali. Lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide. They all contain what? Hydroxide. When you put in water, they decompose into metal ion and hydroxide ions. What about the strong bases and weak bases? This is very simple. We came across the acids. We said there are weak acids and strong acids. Strong acids, they were what? They decompose completely. What about weak acids? They decompose partially. So consider this one. Same principle with acids. This is metal hydroxide. It is a base. When you put in water, it decomposes into potassium ion and hydroxide ion. So completely ionized alkali is called strong alkali or strong base. So completely ionized. So strong alkali is completely form ions. 100% become ions. This is called strong base. What about the weak base like ammonia? Weak alkali or weak base is a partially ionized, partially decomposed. For example, this is ammonia. When you put in water, it decomposes into ammonium ion and hydroxide ion, but it's a partially, not completely. Still, we have some ammonia. Remember this one. This double arrow indicates irreversible reaction. So some of the one ammonium ion and hydroxide ion combined together again will form ammonia. Again, ammonia decomposes into, so it's a kind of equilibrium. So ammonia decomposes into what? Ammonium ion and hydroxide ion. So the most important thing is alkali, completely ionized alkali is called strong alkali. Partially ionized alkali is called weak base. So my students, I want to summarize my lesson. This is the third lesson. Thank you.